Alrighty, folks. We left off with this conversation. We were talking about different ways that energy transfers. We left off, I think, right around, you guys can check your notes to be sure, but right around talking about thermodynamics. And you've heard of those terms, okay? They shouldn't be new to you. Maybe not the second law of thermodynamics, but when we talk about what it actually means in plain English, we're like, oh yeah, I knew that. Cars aren't really great at burning gasoline. We talk about getting them more efficient and stuff like that. It's sort of in that ilk, okay? But there's a lot more to it than miles per gallon. There's heat, okay? The car engine is hot. I think we talked about that. Even us, perfect machines that we are, right? Our metabolism is only 40% efficient.
Better than a car, though.
Yeah, that's very true. Very true. So, the segue to where we're headed here, which is photosynthesis in a minute, seems kind of weird, maybe an abrupt change, but if you think about it, it's really, photosynthesis is an energy transfer. And so that's the first law of thermodynamics, okay? You can either create nor destroy energy, it just changes form. But it's also an example of the second law as well. That it's not 100% efficient. It's hard sometimes. I think we talked about growing all the fruit on the West Coast and shipping it over here, and so that energy doesn't go back into that ecosystem. Remember all that conversation? So it really highlights, and I'm not sure I ever even fully processed that before. So, yeah, this is basically just another slide to the second law, all right? You're constantly putting energy into your system. I used your bedroom as an example, but, animals, organisms are a great example as well. So as I said, photosynthesis, I kind of jumped the gun a slide early there. I think you all know what photosynthesis is. To what level you remember it is totally across the spectrum, I'm sure. Okay, I doubt any one of you can totally regurgitate the formula. Anybody want to try? Yeah. No, and I even garble it. And I don't teach it every semester, but, I get the gist. I could do it in words, but to do the actual chemical equations, like I remember glucose for some reason, and I don't know any formula, hardly any formulas, but C6H12O6. Did I just say that right? I'm not looking at the board. Yeah. Woohoo! So, yeah, for some reason I remember glucose. But that's plant food. Okay? So the whole idea, we know plants need sunlight. We know plants need fertilizer. We know plants need water. Photosynthesis takes that all into account and shows us how the plant actually makes that work for itself. All right? And then it shows us what's not needed from that equation. And that's why we like plants. When you have a small apartment, for example, you want to fill that sucker up with plants. You'll find out why in a couple minutes. Yes, ma'am, question?
Do you have the formula?
Yeah, we've got plenty of slides coming on. We've got like 3 or 4, 5 slides on photosynthesis. So, photosynthesis is, as we said, green plants. In particular, we're talking about something called chloroplasts. Okay? Chloroplasts are the little energy plants inside of plants, pardon the pun. But their job is to convert solar energy and carbon dioxide into sugar. So that's part of the one half of the equation right there. But we'll certainly show you said equation. Probably right now. There we go. So what's that first ingredient? Do a little quizzing here. Carbon dioxide. Good. What's the second ingredient?
Water.
Water. Good. Third? Sunlight. Yeah, well, we do that one. Vitamin D, yeah. So a lot of times, and if you remember this from high school, you might remember a little squiggly line coming down over the arrow. Or a little squiggly arrow coming down over the straight arrow. All right. I couldn't figure out how to make that in typing. So what you would see is 6CO2 plus 12H2O yields, and then over the yields there's a little wavy thing coming down that's supposed to pretend to be radiant energy, sunlight. All right, but we wrote the word sunlight in here instead. And that arrow is yields. All right, C6H12O6, which I just told you was glucose. Good. Plus, well, the water stays there, just got less of it now. Plants are full of water, right? We knew that. That's what keeps them turgid is the word. Sorry?
Then there's the oxygen.
Well, we're getting there. We're getting there. But the water stays in the plant. That's what keeps it the word is turgid or turgid. I've heard, but rigid, as far as, that's what helps it, stand up and stay full. And then, that last ingredient there, it doesn't keep. It doesn't have any use for oxygen, which is a good thing for us, which is why I said you've got a tiny, crummy little apartment or a dorm room or whatever. Okay, first of all, that plant's going to suck up all your CO2, right? That's what we exhale. So all the time you're breathing, you're talking, so on and so forth, you're feeding your plants. Never thought of that. And then, after you feed them, they feed you. They give you fresh oxygen in your room. The glucose, like I said, is plant food. We say here that it stores the glucose in water, all right? But it's utilizing it at some point. You see it needs twice as much water as it keeps. A lot of narrative. Don't try to scribble this all down. And again, have I not posted this on the Blackboard site? Thought I did for you guys. Okay. See a lot of people frantically trying to scribble down everything that's up on here. Please, you have access to it, okay? Feel free to write, but rest assured that you've got access to these. So plants absorb carbon dioxide from the atmosphere and in the presence of sunlight convert it into sugar. Oxygen is an unneeded byproduct. That should probably be a separate bullet. Unneeded byproduct of this process and is expelled by the plants. CO2 in, O2 out. Okay, yep, and that's why there's a break here. There's a special little door, tiny little doors on leaves. Blades of grass have it, leaves have it, and they go in and out and close. For those of you not looking at me, I'm doing my finger up and down here like a little circle, okay? And they're stomata is what they call them. And they're necessary for gas exchange, okay? The gas has to get into the plant somehow. The gas has to get out of the plant somehow. So that's where they go. All right, before we go there, I want to get on the proverbial soapbox for a moment. So I told you how good plants are for your dorm room or your apartment or whatever. This is also why, among a gajillion other reasons, why clear cutting of forests and all that stuff is such a horrible idea. These plants are literally sponges, okay? Especially when we're at a point in life when we're worried about carbon dioxide in the environment, which a handful of people that are paying attention are, okay? Whether it's man-made, whether it's natural, that's a whole different, separate argument. There's no denying that it's rising, okay? Who's the cause? Yep, we could argue over beers as long as you want. But don't argue that it isn't rising. So what you don't want to do to compound that is remove your carbon dioxide sponges, okay?
You do that anyway, usually with farming ones. Sometimes you can grow your own food in your own house or in your own apartment.
Yeah, that's true. unfortunately, it's not just individuals. As individuals, I could almost say you can excuse it, you know? You're doing what you need to do to sustain, to survive. It's corporations, and they're doing it for stupid reasons. Big one back 2000s, maybe late 90s, is they were cutting down all these rainforests to plant corn because, they were going to get that biofuel out of it. All right, which biofuel, again, a separate argument, good, bad, and different. But if corn was meant to grow there, corn would have grown there. And as it turned out, after they took down all that rainforest, they couldn't grow the damn corn because it's not the right environment to grow corn.
And I'm guessing they didn't replant any of those trees, because why would they?
Well, even if they did, it would take generations for it to come back. So there's a couple things here. At any rate, they're not there any longer to suck up carbon dioxide. What do they do when they cut down the trees? Most of the time, they don't send them to make furniture. They slash and burn. When you burn it, you're releasing all that carbon dioxide that it's been soaking up for Lord knows how long. Hundreds, if not thousands of years. So it's twofold. All right? It's really bad. And that's forests up here, too. It's not just rainforests. All right. Cellular respiration. I will admit this is not my strong point. As a geologist, I'm surface processes and critters, which means I talk about the environment and I talk about critters, but getting inside of their cells. So I'm going to stick pretty close to the slides here, which I think you guys tend to appreciate anyhow. Not going to be anecdoting it with too many little side stories. So the energy stored in green plants is released by a process called cellular respiration. Again, you've heard of this in at least one, if not a couple of your science classes through high school. Okay, cellular respiration. There's two kinds. There's aerobic and there's anaerobic. Remember hearing those words? All right. Aerobic is oxygen. Anaerobic, there's that A again, is no oxygen. All right. But that's where the word aerobics comes from, that exercise thing. All right, that was to get the blood and the oxygen flowing through all your blood and everything. That was where's that word came from. So they perform aerobic cellular respiration. In other words, it has to take place in the presence of oxygen. This looks very similar to what we just saw. This takes up with the glucose, though. So remember, we made glucose in photosynthesis. Now, here's the second step that you didn't hear so much about. This is how they process the glucose. So they do need some of that oxygen. I lied to you. I said that's excess plant food. They're just giving that to you. They need a little more oxygen. And they need some more water. So it's a good thing they stored water, right? So what does that yield? That yields carbon dioxide and water and energy. So what we're doing here is we're breaking down the stored energy in the glucose, and we're using it for various life functions. I say in movement. We're obviously getting past plants right now, okay? Plants usually don't move. But this is cellular respiration through the eyes of critters. Okay. But you could just as easily follow this through from photosynthesis, since this was not just the byproduct of glucose, but remember you had 6 waters left too. So kind of neat the way it all works out. And if I haven't said it yet in here, you'll hear me say it many, many times. Science is nothing but us trying to figure out what Mother Nature's doing, okay? And sometimes it seems rather, I don't know what the word would be, to break it down into something like that.
Rather daunting to try and understand, especially since nature keeps doing different things all the time.
That is true as well, but I was looking for something I'm going a different way with it, something a little more minimalistic. In that this whole amazing process that one formula feeds into another formula and so on and so forth. Nature does it without formulas. The formulas are us. and to reduce that amazing life-sustaining function into a couple strings of letters and numbers is what I was saying. It seems a little, I don't know, not appropriate sometimes. But it's an amazing process. Amazing process. So nothing really new on here, just sort of illustrates. I'll give you a second to stare at it. I won't chatter through it. And as I said, before I change the slide, I told you I wouldn't chatter through it, but that bottom right-hand corner there, all right, going back to the second law of thermodynamics, there's your energy lost. Is it really lost? Well, no, you used it for something. But because you used it up for motion, for digestion, for keeping warm, for growing a new sprout, it is no longer in the equation as energy. Unless you want to get into food chains. Gosh golly, is that why we're talking about this? Because what did that new sprout turn into? Well, that new sprout maybe turned into something that the bunny rabbit's going to eat, right? And unfortunately, something's going to come along and eat that bunny rabbit. So then that's still energy. Yeah. See how that all works? The surface of the Earth, we have a solar-based food chain. We have a solar-based ecosystem. Soon you're going to be hearing words, again, that I hope you've heard before. Primary producer, primary consumer, so on and so forth. The base of our food chain is solar powered. All right? To borrow a term. If we did not have that first conversion happening, things would be very different. Or maybe not. How many of you have paid any attention to the weirdness that goes on at the bottom of the seafloor, at the deep sea vents? You heard anything about that? They call them the black smokers, and James Cameron sent a little yellow submarine down there and took all kind of cool videos. No? I might have a slide on that. I hope I do. There's no sun at the bottom of the ocean, right? Yet, we found, hold on, before I go, let me see where this goes. I don't want to get too far off. Hey, I did go there. I thought I might. Yet, we found entire ecosystems, hundreds of miles down, nowhere near sunlight, nowhere near primary production as we know it. Instead of photo, which means light, photosynthesis, these guys are chemosynthesis, chemosynthetic. They fix. When you hear fix in a scientific way, it means eat, basically. They eat sulfur. And it's really, really neat stuff. If we have some time when we're done, if I don't have any video embedded in here, I'll show you. And I paused as I said life would have been really different if we weren't solar powered. The scene down there at the bottom of the ocean vents is very similar. They have fish, they have crabs, they have tiny little shrimps. We don't have the giant black smokestacks and the giant tubeworms at the surface. But hey, you need to have something unique down there. So bacteria are the base of the food chain down there. They fix the sulfur in order to live, and then stuff eats them, and then bigger stuff eats bigger. You know, the same idea of food chain. But it's all based on sulfur, a chemical. In theory, you could probably use any chemical as long as you can adapt life to do so. And that last bullet there is really what it's all about. All right? Again, if you pay attention to this stuff, you know that we're constantly looking for more life out there. Are we it? Is that it?
We're also looking for water.
Well,
water on Mars.
that's a little more it's a little more for our own needs. But just as in pure curiosity, we want to know if there's someone else out there. These chemosynthetic organisms, they have another name called extremophiles. All right, these just aren't these Red Bull guys jumping off of cliffs and all that stuff. That might be an extremophile as well. But these extremophiles were the first, more than likely, the first organisms on the planet. They could live inside of volcanoes. They live a mile down in ice. Okay, extreme environment. That's where the extreme comes from. This is much more likely what we're going to find when they let us know. I'm going to say when they let us know about the life they found on other planets, not when we finally found life. But more than likely, it's not going to be, what we consider the solar-based stuff. There is, where we focused search, what they call the Goldilocks zone. All right, they look for stars that are very similar to our star, the sun, and they look for stars that have planets at about the same distance from them, like our planet. And they're certainly focusing their efforts in that direction. But there are definitely people just looking anywhere and everywhere for chemosynthetic types. So neat stuff. Neat stuff. So I don't believe it is a video. No. I wish they moved their camera, but they haven't moved it yet, so this could be bigger. These are those tubeworms I was talking about. And they're anywhere from a couple feet to a good, 10, 12 feet tall. They're filter feeders, and they eat those bacteria that are working on the sulfur there. Those jet-looking things to the side, those are the black smokers. And what they are is water that gets sucked down into the earth at a plate boundary and heated up. At which point all kinds of minerals and whatnot dissolve into them. And that's why they're so dark looking. And when they spew back out to the surface, kind of just like the geysers that we have in Yellowstone and all those other places, a lot of that material calcifies, or I shouldn't say calcifies, it's not always calcium, solidifies, deposits, precipitates, whatever word you want to use there. And forms these vents, these tubes, these smokestacks. So it was a very surreal kind of thing there, and something we didn't really expect to find. They were just trying to claim that they got to the bottom of the ocean. Cameron wasn't the first one to get down there. He just had enough money to go get us back there. But amazing stuff. Amazing stuff. We first discovered these guys, let's say, late 50s, mid 60s, somewhere therein. There's a much better picture of the tubeworms. But like I said, there's normal looking stuff there too. There's fish, there's shrimp, crabs. So an essentially normal looking ecosystem, but totally not dependent on the sun at all. An even better picture of tubeworms. Goodness, I was really... It's amazing stuff. I was lingering a little too long on it, but... All right. So we've been throwing a couple words around that I'm like, oh, sure, you know these, and a few of you I could see in your eyebrows. You're like, I don't really remember it. Don't worry, we're reviewing it. So you got producers, you got consumers, and you got decomposers. Somebody tell us, what's a producer? Okay? They are in charge of making energy, converting energy. They're capable of making their own energy. That's a great point. All right? So that's what a producer is. They produce energy would be a great way to think about that. Somebody else, what's a consumer? Okay. Just as you guys are all consumers out there in the marketplace, there's consumers out there in the wild. As you will come to see, there's many levels of consumers. But simply put, as she said, they eat the producers. Okay? Or they have to eat in order to sustain their lives. Because they could also eat each other. How about the decomposers? Somebody else.
Decomposers get their energy from that stuff.
Okay. In what manner?
They
break it down.
Nutrients in the dead thing, and they get those nutrients and make that energy from those. Yeah.
Yeah. So it's what we're talking about here, and you'll certainly see this. We're not talking about scavengers, all right, in the trophic level here. We're not talking about the crows that you see on the side of the road, or we don't see vultures around here so much.
Fungi,
but
mushrooms.
It's yes, ma'am. Yep. We're going towards the funguses, even some bacteria. Okay, that certainly do that. And a nice, happy ecosystem. All right, a well-balanced ecosystem. You've got all three of those working together. And, of course, you can expect the lovely diagrams that the book provides to have that well-balanced ecosystem. It isn't always what you find, okay? But for educational purposes, I'm sure it will show all of them. So just like an autobiography is somebody writing about themselves, an autotroph is someone who's nourishing themselves. Okay? And that's a really amazing thing to be able to do. You're like, oh, I feed myself. No, not the same thing. Not even if you go out and grow corn and eat that. Not quite the same thing. These guys are taking a variety of inorganic substances. We've talked about a handful of already. And they're turning them into organic compounds that can be used to sustain life. I don't know why I've got that meh symbol there. But I'm not sure what I was thinking. So on land, all right, the plants are our producers. The plants are the autotrophs. In the oceans, we do have plants, okay, but the algae, which aren't plants, okay, worth noting. Some people are a little confused on that one. The algae and the bacteria are the producers. There's a certain kind of bacteria that contains chlorophyll. It's called cyanobacteria, blue-green bacteria. Again, you might have heard of that. At the moment, we consider that to be first life on this planet, the cyanobacterium. They filled up the oceans with oxygen, and then once the oceans were full, it started to bubble up through the surface. So it's not just plants that can do photosynthesis. All right? We introduced it that way to keep it simple, but now that we're 6 more slides in, right, you guys are prepared, we can talk. Other things can do it too. And I could totally see these being test questions, right? You know, on the water, who are our primary producers? On the land, who are our primary producers? So, put a little asterisk there, maybe. Heterotroph. Hetero means other. Okay? So these are folks that need nourishment from other sources, different sources as we wrote here. They eat producers. if they're vegetarians, all right? Or they eat consumers, if they're carnivores, or what's the other word? Omnivores. What do omnivores do?
They eat
Well, oh, and it's right here. Duh. I was thinking you guys were pulling that out of memory. Omnivore isn't on there, but good job. Omni means all, right? So, your primary consumers are herbivores. So those are eating the plant. Again, we're on land. So in this example, so they're eating plants, herbivores. Secondary consumers eat the primary consumers. Those are called the carnivores. So again, we have our bunny eating the grass, and then we have our wolf eating the bunny. Then you have tertiary consumers. We could have put, if I hadn't started with bunny, we could have put something in between bunny and wolf size that might eat the bunny, and then the wolf would eat that. All right, there's an example there. Ooh, how about a cat eats a mouse and a coyote eats a cat? We got coyotes in South Utica now, so you never know.
A wolf could eat a coyote.
Well, you know, yeah, you know. I was trying to increase in size to keep it, but you could certainly have same size animal. And this is where you want to get your little action figures out and have them. All right. I'm a city boy. I'm a suburb boy, actually. I'm not a city boy. But yeah, coyotes are little guys. You're absolutely right, comparatively speaking. I've only seen the wolves at the zoo. But from what I've seen at the zoo, they can be quite big. I've seen a fox out in the wild, but not coyotes. I've heard coyotes out camping. That's eerie. All right, so do we get the levels here? And again, the main thing is just picture these as a great big matching thing, okay? And I pick simple things because I try to make the test, whether you think they are or not, I try to make the test as simple as I can. So we've got the little bunny. Everyone could picture a bunny nibbling on grass, okay? And unfortunately, you could picture the wolf eating the bunny and so on and so forth. So we try to give you simple examples of what these critters are. So there's omnivore, okay? They eat producers and consumers. And not to get paleontological on you, but that is my part of my background. What determines in reality what you can eat other than availability? What's the true determiner of what you can eat? No, I'm not getting psychological here. Like physically.
Is it your teeth?
Well, good point. I was going for this, though. Teeth. All right. What you can digest. I know.
Humans have like sharp teeth and not so sharp teeth, which means we can eat pretty much everything.
Yeah, for sure. Hold that thought, though, because she's got me off on another tangent that I wasn't really planning on going on. There certainly are, and we've evolved to digest certain things and not other things, and there's something to that. But the main physical thing that we're talking about, and that's almost a chemical thing, is the teeth. Okay, just plain manual physiological issues. And we, as humans, as she was pointing out, we have a variety of different teeth. We have puncturers, we have shredders, we have grinders. All right, and you know there's real words for all of those. But those are our teeth. You look at a cow or a horse, they've got all grinders. So when you go back and through and they're trying to look at whether it's fossil species or even living species now, what is supposed to be their natural diet, all right, your teeth are the best indicator of that. So, detritivore. I prefer scavengers myself, but detritivore is the real word, and since everything else is ended in vor, we'll go with their word. But you guys know these as the scavengers. Carcasses, yes, even feces, leaf litter, etc. Okay, all that stuff lying on the forest floor, there is something out there that will eat it at some point. at some level. And lastly of the vores, we've got the insectivores. And a big, huge, wild guess on what they eat. Insects, yeah. Okay, insectivore. And even at that level, I just recently gave my groundhog lecture. I don't think you guys didn't get the Groundhog's Day lecture, did you? Did I give it to you, though?
You gave us a lecture on groundhog.
Okay, all right. I thought I only gave it once that day for my elementary school earth science class. So as we learn groundhogs, okay, they will eat insects. They will eat seeds as well.
A bunch of birds will eat insects and seeds.
Yeah. So we have another level of omnivore, if you would. So. All right. This is more on the decomposers. And the Sappertroph. Sapro is rotten. Break down dead organic material and use those components as energy. And these are guys that come in after the detritivores are done. Okay, the Sappertrophs are left. The bacteria, the fungi. I'm currently watching that horrible show, Last of Us, with fungi in it. It's not very uplifting, I'll tell you. But the fungi in there, okay, as you know, are breaking down material as well. So there's a couple ways to talk about energy flow in an ecosystem. Right? Food chain is the one that you're most familiar with. Trophic levels are basically levels in the food chain. You've heard them before. All those tropes we just went through. But you guys are most commonly aware of the food chain itself. And actually, even more so, hopefully your teacher then went on to say, well, technically it's not a chain. As you guys very quickly pointed out with my clover, bunny, coyote thing, that, the wolf could come in either way. The wolf could eat the coyote, the wolf could eat the bunny even. So it's not a chain by no means. And I remember in, early on, 6th, 7th grade, they talked about the food chain, and even then, 100 years ago when I was in school, they're like, well, and we quickly learned, of course, that it's a very intricate web. It's not just a chain. But like all things, you got to keep it simple when you're first learning. You keep a nice straight line, and then you could look at all the inner working tangents from there.
It's like playing rock, paper, scissors for years, and then somebody comes along and makes ultra rock, paper, scissors, where there's the standard 3, but there's also like dragon, man, fire, and all these other things.
I have not played that game. The advanced one. I have played rock, paper, scissors, obviously, but I'll have to look for that. Ask my kids. I think rock should always win. Rock can tear paper. I never understood paper covers rock. Rock's strong. So again, back to trophics. One more time, just to pound this into your head. First level of trophic level is producers. Second is the primary consumers. Third level is the secondary consumers. Just remember, it's always off one notch because we have the producers at the first level. Okay? It's always off one notch. So what wonderfulness do we have here? Oh, we have I forgot about snakes. So we've got little mousy eating the plant. We've got the snake eating the mouse. We've got the hawk eating the snake. And what are we going to do to the hawk? We'll get it hit by a car. All All right, when it was struggling to get the snake up, it flies in front of a semi, and it gets smashed. I'm sorry, we had to kill the hawk somehow.
That was a bit more graphic than you.
I'm sorry. And it's now sadly by the side of the road. I did say sadly. And now the fungi and the bacterium could move in. But again, you know there'll be various birds, scavengers coming in as well. Okay. And while I don't emphasize it a whole lot, again, going back to the second law of thermodynamics, we've always got this heat loss to the environment. Okay? Always got heat loss to the environment. There's a web.
Wow.
And again, it is way too small for the front row, let alone the back row. Pretty sure, actually, this is out of Wiley. When I first wrote this lecture, we must have been using a different text. You guys have Raven now. But I could guarantee you Raven's got a similar picture in there, okay? That shows, just as an example here, we've got insects. And, you know, insects are amazing decomposers as well. They're going to come in and break down, actually detritivores, I should say. Worms and ants, okay, are great at breaking down that material. What do we got? We got deer mice, we got spiders, insect larvae. Those are typically food, unfortunately, for the insects. Red clover, some birds, blackberries, hawks, deers, foxes, chipmunks and bunnies, and owls. What owls eat? You guys know that one? Did you do owl pellets in school? Yeah, that's a mixture of fun and gruesome. I don't know. It's kind of nasty. It's kind of cool. Where it crossed the line, I mentioned my teacher class earlier. They're in the Oneana program to be K through 6 teachers, and we usually try to end the year by growing butterflies. That's kind of cool. But it ran in the fall one semester, and we can't really release butterflies in December. So I had to come up with something else to do. So I bought a whole bunch of owl pellets. And so they were picking through them. But then I said, okay, I got it really fun. We're going to finish this up in a really fun way. Again, I'm a paleontologist. I thought it'd be fun. I said, all right, now I want you to try and reconstruct. And they're like, no. So we didn't reconstruct any mice. But did you put them back together in the end? Well, good for you. I thought so. We're not in the norm, I think, on that one, though. But at any rate. But yeah, you know, see if, I mean, it should all be there, right? All right, so anywho, so owls, you know, they're not sitting there eating nuts and berries or Tootsie Pops. They're eating, you know, mice and whatnot as well, so. Food web. Bada bing. All right. Let me close up this video.